Question 7. So for part A, this is a biggie, 10 marks for this. So start off by getting your diagram sorted. Make sure you understand this. Make sure you've got the normal reaction. Make sure you've got the friction coming down the slope given there's movement up the slope. Make sure you've got the tension pointing upwards here and upwards here. So we're going to have to create a simultaneous equation to allow us to work out the acceleration. So starting off with particle B, if we resolve perpendicular to the slope, we know the normal reaction equals 3g cos theta. I don't know why I've called it alpha, it should be theta. 3g cos theta. Okay, so that allows us to work out that the normal reaction is 36/13g. Now resolving up the slope, we have t minus 3g sin theta minus f. So that our net forces is t up the slope, and the blue force being being 3g sin theta and f coming down the slope. So our net force here is f equals ma. So our net force being this. Remember that the friction is mu times the normal reaction, so that's 2/3 from here times the normal reaction that we've just worked out being 36/13g. So that f is replaced by that. So this net force equals ma, the mass is 3, so 3 times a. So that allows us to get as far as t minus 29.4 equals 3a, and that's equation 1. Now moving over to for A is much more straightforward. Our net force downwards is 7g minus t, so that's our net force equaling ma equaling 7 times a. So that is equation 2. So we've got a simultaneous equation to solve. To eliminate t, I've just added these two equations together. 1 plus 2 gives me this, and that allows me to solve for A being 3.92 meters per second squared. Now for part B, think what's going on here. Our initial speed is 0, we're travelling a distance of 1 meter. We've just said that we're accelerating at 3.92 meters per second squared. So using the Suvat equation, v squared equals u squared plus 2as, we can solve for v. V is 2.8. Now for part C, before we can really get into this, we need to work out the deceleration which is going on once the spring breaks. So let's again, using Newton's F equals ma, our net force is going to be minus 3g sin theta. That's going to be our force, and minus f. So our net force is this, equaling ma equaling 3a, giving us a deceleration of minus 9.8 meters per second. So that's our deceleration. So using Suvat v equals u plus at, we know our final speed is 0 because that's when it comes to rest. We know our initial speed, we've just worked that out, is 2.8 meters per second. That's our initial speed after the string breaks, because it's the final speed before it breaks. So that's our initial speed. We know our deceleration is minus 9.8, leaving us with t as our unknown, so we can work out t to be 2/7 seconds.